Today's lesson is regarding points of concurrency and the segments that create them. Remember, a point of concurrency is where three or more lines intersect. Let's go ahead and look at the first part. We want to match the picture to its vocabulary word. So let's kind of think through. Let's start with mid-segment. Mid-segment. Now, a mid-segment we talked about in our last video, and it connects the midpoints of the side. So let's kind of look through our picture. So option A, that makes a 90 degree. That's not helping us. This one makes 90 degrees with bars, with congruent pieces. That's not a mid-segment. However, C connects two midpoints from opposite sides. So option C is going to be a mid-segment. Looking through, the only other option that has midpoints connected is I. Remember, parallel sides, we have like mid-segment here is parallel to the side here. So option I is a mid-segment. The next one we're going to focus on is altitude. Now, what altitudes do is they only do one thing. They make 90-degree angles. That's all. So let's go ahead and write mid-segment connects midpoints. So mid-segment connects midpoints, altitude only makes 90 degrees. That's all it does. So looking at my options, option A creates a 90-degree angle. So I'm going to go ahead and mark option A as an altitude. Now B is not an altitude because it also bisects a side. So altitudes only make 90 degrees. So looking at my other options, this one again is marking sides congruent. Option H, however, matches option A. It makes just 90 degrees. So H is also an altitude. All right, the next one, angle bisector. That means it cuts an angle in half. So an angle bisector cuts an angle in half. So we should be looking for a segment. We should be looking for a segment that starts at an angle and then just divides that angle into two equal pieces. So this doesn't start at an angle, so I'm not going to pick that. Option D marks two little pieces of an angle congruent. So option D would be considered an angle bisector. The only other one that starts at an angle and has any information near the vertices is option G. Notice how they've marked the two angles congruent. So D and G are my angle bisectors. Next is my perpendicular bisector. Now a perpendicular bisector makes 90-degree angle and cuts in half a side. Cuts a side in half. So a perpendicular bisector makes a 90-degree angle because it's perpendicular, and it cuts a side in half. So I'm looking for my 90-degree angle. So looking at option B, I've got my 90-degree, and then I also have side AC being cut in half. So option B is a perpendicular bisector. Option E and F only bisects, so it can't be perpendicular. However, option J has the actual 90 degrees, so option J is also a perpendicular bisector. This now leaves us with median, and a median cuts a side in half. Okay, so median bisects a side. So looking at my only two options, notice how I have my two pieces congruent. So option E and option F are my medians. Now, these are all segments, so let's move down here to matching the points with the lines that are created with the location facts about the point of concurrency. So let's go ahead and just start with orthocenter. Now, orthocenter is the point of concurrency. So underneath here, these are all the points of concurrency. It would help, oh no, I just saw it right. Points of concurrency. These are the segments, and these are the facts about the points. So let's start at orthocenter. The orthocenter is where all of the altitudes meet. And honestly, there's nothing special about the altitudes, so they actually have no fascinating fact about them. The in-center corresponds to the angle bisectors. In-center, angle bisectors. And the best way to know what is special about the angle bisectors is they create a circle inside of the triangle. So that means that the in-center is equidistant from the sides. So when I draw a picture of an in-center, the circle is inside. Circle is inside the triangle. So the important, interesting fact about an in-center is that the circle is inside of the triangle. The next one we have is circumcenter, and circumcenter corresponds with perpendicular bisectors. Perpendicular bisectors, when they intersect, they're equidistant to all of the vertices of the triangle, which is just fancy to say that the circle is outside of the triangle. So equidistant from the vertices means the triangle is going to be inside the circle. So circumcenter, the circle is outside the triangle. And lastly, we have the centroid, and the centroid is created by intersecting all the medians. The smaller section of the median is 2 times bigger than the larger section. But another very important fact about the centroid is that it's referred to as the balancing point of a triangle. So remember in class, I showed you this bird. Okay, this little bird. Remember, this is actually a triangle, and the bird balances on your finger because its beak is a centroid. So it's the balancing point of this triangle creating this bird. And notice how it's not moving, like it's balanced on my finger. So the balancing point of a triangle is called the centroid because it's in like the center. It's the average of all of the medians. So let's go ahead and finish up with just information about the locations of the points of concurrency. The circumcenter, remember, that's where perpendicular bisectors meet. The in-center is where angle bisectors meet. The centroid is where medians meet. And the orthocenter is where altitudes meet. Now, since the centroid is the balancing point of a triangle, if I'm balancing inside of my triangle, that point is always located inside. I can't balance a triangle outside of the triangle. So the centroid, if the triangle is acute, it's always inside. Obtuse triangle, it's inside. And if it's a right triangle, it's inside. I can't balance on a triangle if my balancing point is not inside of the triangle. The next one that's always inside is the in-center. And the best way I have to remember it is in-center, inside. The circle is inside the triangle, and the point is always inside of the triangle. So it doesn't matter the type, it will always be inside. As far as circumcenter and orthocenter go, if the triangle is acute, acute will always be inside as well. Obtuse for circumcenter and orthocenter. Obtuse, think of the O as in outside. So these points will be located outside of the triangle. And if it's a right triangle, it will actually be located on the triangle. Now the circumcenter, when it's on the right triangle, the circumcenter will actually be on the hypotenuse. The orthocenter will be located on the 90-degree angle. Okay. So the important thing to know about these pictures is going to be being able to match the words, the points to the lines, and then their special fact. Remember, centroid is the balancing point, circumcenter has the circle outside, and incenter has the circle inside.